little girl.
Geology.
Baby, since I've been loving you, yeah.
Geology.
I'm about to lose my worried mind. Ah, yeah.
Geology. Welcome everybody to the Mini Geology radio show. This is program number 19, and in this program of Mini Geology we'll talk about the co-evolution of Geosphere and Biosphere. Our guest today is Donato Giovannelli. He's professor at the University of Naples in Italy, affiliated also to Rogers University in New Jersey, here in the US, and the Tokyo Institute of Technology in Japan, among others. Donato, you are one of the few young Italian voices with a strong commitment to outreach in science. Thank you for that and welcome to the program.
Hi Daniel, thank you very much for inviting me. It's a pleasure to be here.
Donato, tell us about this passion you have for outreach. Where does it come from?
I think it stems a bit from my own curiosity. When I was a child, I was always asking questions about what people were doing. Was it in a research setting or in a work setting where people were doing work? I would just ask, why are you doing this? What are you doing? Why is that important? And I think for a long time, science and academia especially have been very detached from society. And this is something that has been changing in the past 10 years or more, perhaps. And what we call outreach and the third mission in Italy is becoming more and more important. And I think it's very important to give back to the community and share what you're doing, share how you use public money, share where our society is going. And I think it's important also to build trust.
Donato, why do you say that there was a shift 10 years ago or so regarding the outreach?
I remember I was a young student when a famous book came out, which was referring to the ivory tower, in which academics have been keeping themselves closed from the public from a long time. And I think that was an influential book at the time. Perhaps the movement toward outreach and science communication had started long before that, and I don't remember it because I was too young. But I remember a lot of talk about that book at the time, and I remember a lot more emphasis being put in Italy, at least while I was a student in Italy, into communicating your science to the public. And some of my professors told me that since we use taxpayer money to do our science, it's only fair if we share with them what we do. And that's what I do all the time, both as outreach and with my years in number report on my website.
Who are the people that you target for your outreach? Who do you want to talk to?
I think my parents are the ideal target for the type of outreach I do most of the time, which means there are people that have gone through high school and bachelor's at university or and work in their life, people that have always been curious and they read a lot of books, people that like knowledge and want to know more about how things work. And you just need to take the time to make analogies and explain them what you're doing without getting too technical.
So let's have a try in here. So give us an example of what you would say to your parents about the relationship between this magical duet that is the geosphere and the biosphere, which, by the way, is the main topic of your research.
Probably we all heard about evolution, biological evolution, and that's what we study in school all the time. Unfortunately, there's less of the geological evolution studied, at least in Italian high schools. And when you think about geological evolution, it's taught only like a backdrop. So geology is doing its own thing, and biology is evolving on top of it, often catching up with changing conditions. I always think instead that the two are actually interacting and working together. It's like the environment changes and biology changes with the environment and changes the environment at the same time. Lately, I've been drawing a sketch for some of the high school students I've been doing outreach, on which I depict the organism as a geometric figure and the environment as a very rough-shaped line, and the geometric figure perfectly fits with the folds of the line. And as the two move along, the shape is smoothing the environment, is smoothing this line, and the two end up being a straight line and a sphere. I think it's an abstract concept, but it's a beautiful one.
What are generally the topics that you would like to communicate to the people that you talk with, again, when we are reaching out?
When I speak to my students, I want to first and foremost give them excitement for exploration. We tend to teach in school concepts, and we teach disciplines as if they're set in stone. We tell them concepts, we tell them theories, how things are, but few times I heard my professor tell me all the things we don't know about how things work, all the excitement about finding out how things work. And I think that's what is missing a lot, is the excitement of knowledge. Even as scientists are portrayed in movies and in books, they're always cold, calculator, always very data-driven, and there's a lot of emotional aspects in science, and the biggest emotion you have is the one of discovery and exploration, and I think that something needs to be put back into science and, explained to the public. The public can get very excited when you speak with them about unknowns and exploration and discovery.
So let's get excited, Donato. Let's get excited and tell us, what are those unknowns that you know that you would like to research and your community investigating the relationship between geosphere and biosphere are doing nowadays?
I started out thinking I would have become an explorer when I was young. And I was maybe 14 or 15, and it was incredible for me to think that 20-something people had gone to the moon, and only 2 people at the time, 3 now with James Cameron, went to the bottom of the ocean in the Mariana Trench. It was really mind-blowing for me. Why did we send more people on the moon than we have on the bottom of our ocean? Why we know so little about our deep sea? And that question of why we know more about outside than we know of our own ocean when our planet is covered by water really drove me into the science. And then, discovering the beautiful interaction that life and planet have had over time. There's one big example that all the scientists know, which is the increase of oxygen, the great oxidation event. But there are a lot of more nuanced things that may happen. And thinking about why, to me, it became really to think about why this planet is what it is and why neighboring planets, they're not. Why Mars and Venus, they're different. Why they went in a different direction. Why there's life here and we don't know life anywhere else. And everything to me started with why we didn't send more people to the bottom of the ocean.
Yeah, so to know the unknown is one of the most exciting things, which is exactly what the explorers aim to. So Donato,
I think that curiosity is what drives children toward their passion for life. And there's something beautiful and magic about exploration, which is very much linked into geoscience and natural science, all the field aspects, all the mapping, all the research that can go in the field. And that kind of excitement, I think, can draw more people into the sciences overall. It's just, we just need to bring it back to the public.
Part of your outreach is a document that you release every year, and is in your website, and the title is The Year in Numbers. Is a report of your activities. Can you tell us more about this?
That started a few years ago while I was a visiting scholar at the Institute for Advanced Studies in Princeton. Pete Hutt was my host there. He's an astrophysicist. And every year for the past, 15 or 20 years, he's been publishing a year in number report where he details all the activity he took part in, all the papers, all the meetings, all the conferences. And that's his way to keep himself accountable, I think, with the public. That's his way to be transparent about how he uses money. Even if the Institute of Advanced Studies is not publicly funded, he's got private donor mainly. It's still a way for him to let everybody knows what he's been up to. And I thought that was very important. The teaching as a professor is somehow more apparent. Everybody knows what you've been teaching, but it's more difficult to know what you've been working on, what projects, how many grants, how many papers, how many activities, how much outreach have you done. And I think it's very important to report it. So for the past 3 or 4 years, I've been doing it. Every year in January, I publish the previous year.
So this is an act of transparency about your activities, which are sustained by the society. But does it help you when you have to write down the things that you have done, or are you inspired by the things that you have done, or maybe depressed by the things you have not done?
I have to say I'm seldomly depressed. I'm a very positive guy, so overall there's very few things that depress me. It does help you, because sometimes you feel like you've been involved in many things, but you didn't really accomplish much. And I have to say that putting on paper actual numbers of things you've been doing, and a list of the activities you've been involved in, and a list of the data sets you've been working on, it's satisfying at the end of the year. So there's definitely a component of self-reflection that goes into that write-up. But I really feel like it's a due act to the public. It's something that I own to the people that are paying my salary.
That is an extremely valuable suggestion to write down what we have been doing during the previous year. I really think that it could have a positive feedback on the things that we would do the following year. By the way, any feedback? Do you have anybody reading your document, the year in numbers, and asking you things like I'm doing right now?
Well, I know people are watching it because Google Analytics is telling me the page is clicked. But I received a few questions about why am I doing this, but no real feedback.
Okay, here is one feedback. So, Donato, if you had to... so I'm going to tell the audience what you write in this document. The year in numbers for Donato Giovanelli is about a list of activities he made. And I here enumerate the activities so that the audience knows what we're talking about. There are meetings, conferences, presentations, lab work and analysis, field work, writing proposals, reviewing articles and proposals, writing articles, teaching to classes, volunteering teaching classes outside of the university and high school, reaching out like he's doing right now. He has editorial roles. He's a reviewer, as I said, and also a supervisor. So my question, Donato, is if you had to dry out your abundant activities, what would you keep?
Oh, I love the teaching. And sometimes I think my job is twofold. That's the way I justify my job to myself. I've been thinking sometimes, why am I doing geoscience? I love them, but what's my bigger contribution to society? And I think I see my job as an academic as twofold. First, I have the honor and the responsibility of mentoring the next generation of citizens, not just scientists, citizens, critical thinkers. And I think that's very, very important, especially in today's society. And my second job is to advance human knowledge. And when I started seeing my job as this, it became, my focus went from the pure science and the publication more with the interaction with the students and the teaching the students and the interaction with students at every level, like high school you mentioned it, and what I give back to society with my job. And I think if I had to distill down everything and I will keep something, I will definitely keep the teaching. It's really satisfying for me, and I feel it's very, very important for what I do.
So I see teaching for mentoring the next generation and probably research for advance the human knowledge, right?
Yes, absolutely.
And about the very first one, Donato, mentoring the next generation of citizens, how do you mentor them beyond explaining the science that you do and the concepts that you study?
I'm teaching two classes right now. One is in applied microbiology and one is in marine microbiology. And I always, when I start my classes, I start both classes in the same way. The first class is about what to expect from my class and what to expect from overall the university experience. And we start discussing about basic versus applied research. For me, talking with them about basic versus applied research is to bring their focus on how perspective can change on topics. At the end of the day, I do want to teach them some encyclopedic knowledge, so some concepts and some ideas and some what they can find on textbook, but I want them to learn how to think critically about anything I tell them, and I want them potentially to challenge the connection I'm trying to make for them. Because at the end of the day, what they need to learn from university is to find knowledge when they need it and think critically about problems. If I can make them do these two things, I'm far more satisfied than if they know by heart the entire division of phyla, marine taxa, things like that.
I would press you to try to explain how do you teach your students to think critically?
So one thing I do in class, for example, in the applied microbiology, I'll try to make for them connection between different topics of applied microbiology. And I try them to make them see how very general concepts in ecology, for example, they become applied to different issues. For example, I'm very interested in how metals are involved in microbial diversity and what's the interplay there. And when we speak about different topics in applied microbiology, for example, bioremediation of hydrocarbon spillage, or human gut microbiome, we always end up seeing how basic concepts like basic nutrients of element limitation can link fields that look very far away from each other. And sometimes students know very well the single topic, but they struggle with connection. And for me, showing them larger connection helps them to develop this critical thinking and how to connect things that are seemingly far away, but they're in reality much closer than expected. That's definitely one way I ask them to do that.
On top of these abundant activities that we have been describing in these two basic ones about teaching and researching on Geosphere and Biosphere, you, Donato, you are involved also in another interesting duet, which is innovation and business. In fact, you are a co-founder of 3 startups, one on nanotechnology, one on biotechnology, and one on investment. So how do you manage all this work?
This came out of when I finished my master's degree, I started a PhD program that then I had to abruptly stop for a number of reasons. And it took me a couple years before I went back to graduate school. And in those 2 years of interruption from academia, with my brothers, my girlfriend at the time, now my wife, and a couple of other friends, we started, thinking. My brother he's a mechanical engineer, was going on and on and on about carbon nanotubes and nanotechnology, and he was saying there was the right moment to do something and composite material. So it started more like a bet. I was not working at the time, and I said, okay, let's put my time into something productive. There was a business plan call at the time. We went for it. We won the seed grant to start the company, and this was 2010, and the company has been going ever since. And I think I got, when I started that, it was more like a bet and a game with my brother and my wife and other friends. And then it became something of fascination for me because it was such a different way to approach scientific problems. And there was this big debate between what was basic research and what was applied. Our CEO right now is always talking about applied problem. I don't really see this big gap between basic and applied. And being with my feet in both shoes, the academia, especially in my field where we do environmental microbiology, mostly what people call basic research, and a company that is doing advanced composite carbon stuff. It was very interesting to see this perspective and hear this debate develop. And from there, everything else came by. I like the innovation. I like the entrepreneurship concept and what it stands for. So I've been doing other stuff.
By the way, is the entrepreneur in the way of the researcher or vice versa? Or as you said, you intermingle them very well and they feedback each other?
In my view, they feedback each other very well, at least for my persona and what I've seen in interaction. And
in which way?
I think right now, I think we should give more of our science students some economic tools to use in their career, be either academia or outside, because at the end of the day, we all have to deal with the economics of our society. And vice versa, I will give all the economics students some basic science, which in some places is not really done at the university level, to be able to understand how society is working around economics with things and planet and environment. And I think this dual view on the research I have, both from the entrepreneur side and the researcher side, has helped a lot the development of the company.
Donato, I don't want to forget another interesting side of your activities, which is the winemaking. How is that going?
That's an investment for my retirement, Daniel.
Okay. So this is just an investment. It's not you making wine.
No. I do wine. I'm learning how to make wine. I'm helping out a friend that has a winemaking since 3 generations, and I'm making wine with him. And I spend every Saturday and most of my Sundays in the winery. And I think this is a retirement investment, because if I think about my future, I definitely want to have very good wine with me, whatever the path leads me. So learning how to make good wine is probably a top priority right now.
Being in the winery, especially if you are an enologist, after all, is nothing else than being a chemist.
Yes, it is. And right now, as a microbiologist, I'm actually very, very interested in some of the community dynamics that happen within the wine, and how the terroir, the soil chemistry, and the natural community in the wine, in the grapes and in the soil can influence wine. It's actually very fascinating and very complex. It's
I
beautiful.
see now. So when you, in your web page, you write that you study the extreme environment. So wine is the extreme environment for the microbes.
Wine is a good extreme environment.
Which kind of wine do you produce? Montepulciano, maybe?
Yeah, we do Rosso Conero, which is a Montepulciano grape, and we do Verdicchio, which is a white
Verdicchio di Jesi.
Verdicchio dei Castelli di Jesi, yes.
I see. All right, so we have now known a little bit of the multifaceted character of Donato Giovannelli, which is a professor at the University of Napoli in Italy and affiliated to the Rogers University in New Jersey and the Tokyo Institute of Technology. So let's move to your research, Donato. You gave us an example of the relationship geosphere, biosphere, and their coevolution while we were talking about the outreach, something that you would tell to your parents or my parents. Can you give us now more thoroughly examples of planetary scale processes where the geosphere and the biosphere co-evolve?
Some of the latest research we've been doing involves on volatile cycling. So thinking about how microbes can really change the volatile cycling at planetary scale. Now, this is not big news. People have been studying contribution of microbes to oxygen, or in certain case, contribution of microbes to methane cycle, for example. But in the last 2 or 3 years, with a group of colleagues, both from US and international, we've been thinking about subduction zones, which is perhaps one of the most charismatic feature of our planet, with the deep sea trenches and volcanoes. They really shape the surface of our planet. And what we've been thinking is that a lot of the volatiles that are moving through the subduction zones are of possible interest for biology, and probably biology is interacting with them. And I think this is fairly new in the way we've been approaching this, and has been very exciting in the last 2 or 3 years. And I think that's something that can lead to new understanding about how, for example, long-term climate stability of our planet has played out, thinking about how microbes have been mediating volatile exchange from the mantle to the atmosphere.
What are the most difficult topics when you try to study the coevolution of two spheres that have such a strong character, like a geosphere where you study the rocks, and the biosphere where you study the life?
I think time scales overall is a problem, both temporal and spatial scales. We think about geology as a process that is working on large scales, both temporal scale, very long time scale, and very large spatial scale. And when you think about biology, especially microbiology, you think they are tiny microbes, micron scale, and they usually work on the order of, the most of the microbes we can cultivate, they work in the order of hours, minutes to hours. And then there's all the environmental microbes that probably take much longer, but we're still talking about very small scales compared to the geology. And I think also at the conceptual level, integrating this difference in scales is a challenge. And it becomes also a challenge when you go to the field and you try to measure things that are meaningful to this interaction. I think this is the biggest hurdle when you try to think about the coevolution of geosphere and biosphere.
Do you mean that researchers studying the biosphere, they are pushing the envelope to study fossil microbes?
No, I didn't mean that. There are a number of people that are doing great job with working on signature of possible early life, also fossil microbes. But what I think is that when I go to the field and I measure the biomass of my microbes or their contribution to removing CO2, how much CO2 my microbes are using or oxygen, it's very difficult then to relate back to the geologic scale at which processes that are controlling CO2, for example, are working. And I think that's one of the biggest challenges. That's where I think in the future we need to get very creative.
In talking about CO2 should stay in the ground to avoid further global warming, as we are listening from all corners. But which role does biology play in moving carbon from the surface to the interior of our planet so that there is a CO2 sequestration process?
Biology definitely has been playing a huge role in CO2, and it's interesting because in this moment we are talking about biology playing a role in CO2, but by the way you made your question, you removed humans from the biology question. It's like, we're thinking about a separate sphere for humans. If you think over time, biology, human included, being biology, we played life has played a huge role in moving CO2, both back into the planet with organic carbon burial in the ocean, biological carbon pump, and probably mediating what is coming out of the planet again. Our latest work showed that microbes can remove a lot of the volatile in forests and volcanoes. So I think the impact has always been big, and humans now are accelerating the rate at which some of these exchange have been happening, which is frightening if you see the effect.
I guess that in order to study this coevolution of geosphere and biosphere, you need very important collaborations. What are the collaborations that excite you the most?
I have a group of people with which we basically spending a couple hours a week on Skype to just work on data together. Karen Lloyd from the University of Tennessee, she's a microbiologist. Peter Berry from Woodsole Oceanographic Institution is a noble gas geochemist. Matt Schrank from Michigan State, also a microbiologist, and Martin Demore from the Volcano Observatory in Costa Rica. I think those are all early career scientists. They're about my age, and we all working together to think about this geo-bio coevolution and the interaction of microbes with this large planetary scale. This is my core group of collaborators right now. And then I've been blessed over time to work with people like Robert Hazen at Carnegie, or Paul Falkowski at Rutgers University, or Costantino Vetriani. I see these people I'm collaborating with more like my mentors, and they really helped me out develop the concept I've been working on in the past.
What did your mentors give you in the time that you spent with them? And what do your collaborators give you now when you do the Skype meetings?
I think all of them, they gave me an appreciation for interdisciplinary work and science. I'm a microbiologist, I'm actually an ecologist by training, and then I did a PhD in microbiology, but I feel I'm actually a closet geologist. My office is filled with rocks and crystals and minerals and every kind of rock stuff I can bring. I think spending time with them really gave me an appreciation for connection you can have between the geo and the bio. And especially Costa Vetriani, Paul Falkowski, and Robert Hazen, they really helped me out in develop the concept I'm working on. And they also gave me an appreciation for big picture type of thinking, which is something in Italian school at university you don't really get exposed to unless you end up working there later with good mentors. There are some great people at CNR also that encourage this type of thinking.
So integration and big picture.
Integration and big picture.
Big picture is a cultural thing. Is just a change in the point of view, but integration, it implies that you need to learn something. So how many disciplines do you need to master to understand this studies, this coevolution that you are doing? It's not easy going back and study the basic of other disciplines.
It's not easy, but it's fun. And I tell you that because I'm reading through my petrology book right now. But I don't know how many disciplines you need, but definitely you need to be able, you're never going to become an expert in the other discipline, but you need to be able to talk with people from the other discipline. And that's very, very important. And that's when, some basic knowledge about the other discipline will help you a lot.
So you're reading now your book about petrology. How much do you have to know about a discipline that you don't master in order to talk with the others?
I don't know how much you have to know. I would ask how much can you afford to miss in order to have a meaningful conversation with somebody else. I'm going to tell you something. We were in the field for the first time a couple of years ago, or 3 years ago now, with this group of young people from different disciplines: geochemistry, mineralogy, petrologists, volcanologists, microbiologists. And we were all talking about this new project that the Sloan Foundation had funded at the time, which we had called Biology Meets Subduction. And we were all talking about subduction and volatiles and cycling and microbes. And after about 3 days of talk together, we realized when talking about volatiles, we were talking about different things. So volcanology, when talks about volatiles, is thinking mainly about waters and then CO2, hydrogen, and other stuff. Biologist never thinks about water as volatile. It's liquid. It's the universal solvent. It's not even in the category of volatiles. When I say volatiles, I think about hydrogen, methane, CO2, and volatile organic carbon. So even in very basic words, there's different meaning. There are field specific. And it took some time within us to be able to talk. And I think that's, unfortunately, this has been not encouraged enough in the classic academia, because you end up in place, there are a department of chemistry, department of geology, department of biology, and you're surrounded by people that speak the same language, and you're very comfortable in speaking with them, but there's not a lot of chances to bridge with other disciplines. And I think I've been very lucky in the different places where I've been, because when I was in Italy, the CNR, the Institute for Marine Science, was marine science. There was biology, microbiology, geology, geochemistry, the same at Rutgers University, the Institute for Marine and Coastal Science. And then both Princeton and the Earth Life Science Institute in Tokyo are very multidisciplinary, very interdisciplinary focus. This has helped me a lot to see how much of a gap there is when you speak with other disciplines, how much work it needs. And so I don't know how much knowledge you need to have, but I know that you need to put an effort to create common ground. And to do this, you need to spend time with people.
So Donato, with your international exposure in 3 different continents, do you see that are we moving towards a fluid professional figure that masters different disciplines, or that specialize in those conceptual areas where there is overlap between disciplines? Because we were taught in our schools, probably by professors, that they were monolithic, and they were the professors that they knew about that discipline. While now maybe we're moving to something more fluid.
I think the amount of knowledge we have requires you to be specialized in a domain, but at the same time, I agree that fluid is definitely the future. So I think you need to be a specialist in something and then being a very good generalist to be able to communicate with others. Unlike what a couple of years ago in a workshop we had organized, Paul Falkowski, at the end of 3 days of this 4D workshop, they brought together bioscience, geoscience, and data science to speak together about grand challenges of working together in geobiocoevolution. After 3 days of talks and beautiful breakout session, Paul Falkowski was reporting back from one of the breakout and started saying, we spent the last 200 years breaking disciplines apart, becoming specialized in something. And I have the feeling we're going to spend the next 200 years being natural scientists again, bringing things back together. And I think we are in this phase right now. After a long time of specialization, there's more and more the need to integrate. And the word interdisciplinary research is now, hot word, common in every proposal, on every request for proposal. And I think definitely we are going in that direction. We're becoming more and more integrated. And there's a need for people that are able to cover this overlapping area, definitely.
This is very exciting. I really hope that you can convey this message to the students that you have around you, the people that they can learn from you, that you are so lucky to be exposed to so many cultures in different countries. By the way, you just mentioned United States, Japan, Italy, where you are at the Università di Napoli. And in fact, I would like to ask you to compare and contrast the research that is done in these 3 different continents, because you are an exceptional person that has the capacity to deal with all of them, and you are affiliated to an institute of research in 3 different continents.
I think there were once schools about different way of doing things, and now with the globalization of science, things have got more standardized in different places. That meaning that you can. I basically keep doing the research in the same way I always done in all 3 continents. It's just about the enrichment of interacting with new people. There are, however, some difference between the 3 countries that I think, for the case of Italy and US, for example, are dictated by, is a reflection of the level of funding going to basic research. For example, the U.S. is a land of opportunity in terms of experiments. If you think about a very good experiments, there are very good chances that you get funded to carry that out no matter what the cost. In Italy, it's often quite the opposite. You need to think how to make your experiment as cheap as possible because most probably you're not going to have the money to run the good version of it. So there's definitely some difference in way you approach the science, which are more due to the environment rather than cultural difference in the way you approach the problem. And even in Japan, where people often mention a different way of Oriental philosophy of approaching problems with respect to Western, within academia, I felt like the way they approach science is exactly the same. And there's a lot of great contribution and collaboration I have there, and it's been fantastic.
Donato, I read that you are editor of a special publication in American Mineralogist. The title is Earth in 5 Reactions. Do you want to talk about this?
This was a very cool concept that came out from one of Craig Manning's statement. At one of the meetings with the Deep Carbon Observatory, he stood up and he said, serpentinization is the single most important reaction in the universe. And, when you make a statement like that in a room filled with deep earth geologists and volcanologists and biologists, everybody has something better to say about what's the greatest reaction. So somebody came out with a cool concept. If we had to describe our planet with only 5 reactions that made our planet unique, what what this reaction would be. And it took some time to build a consensus. We had a big workshop with about 60 people invited from everywhere in the world just to discuss. And I think right now the way this special issue is coming out is going to be a very interesting teaching tool, because at the end we didn't select single reaction, but we selected classes of reaction. For example, carboxylation, decarboxylation, or hydration, dehydration reaction. And within the special issue, there are 6 papers which are review. Each one of these papers is talking about a single class of reaction and is showing how the biology and the geology are actually controlled by similar chemical reactions. It's like bringing into focus the geosciences and the biosciences from the chemical lens. And for example, how hydration and dehydration reaction are very important for serpentinization and for fluidity of the crust. At the same time, they're also the reaction to drive the polymerization of proteins and biological molecules. I think this way of showing students how geo and bio are connected by chemistry could be a very interesting teaching tool, and I hope this collection is going to be used that way.
How do you define the most important reaction? What is that makes them important?
I was saying it's a very arbitrary process, of course. The way we did it, we started with asking, is important for what? And we said, okay, what reactions are important, are the most important to make our planet what it is today? So to make our planet habitable, to have life, to have the planet we know right now. And then we designed a set of questions which were, what do you think is the most important reaction in terms of how widespread it is on the planet? What do you think is the most important reaction regarding the function that carries on the planet? What of this reaction you think has been important through time on the development of the planet? And we sent these 20 questions out to the entire Deep Carbon Observatory community, which is about 1,000 scientists, and we got a few hundred response back. And then these were compiled together, and all the people that, many of the people that gave responses were invited to a workshop to discuss it. At the end of the day, it's not really important what reaction we chose, and if these are really the most important reaction. I think it's a good way to get people speaking about the connection between geo and bio, and I think it can turn out to be an exciting way to teach about this connection. So I don't think there's a lot of emphasis on why carboxylation is among the most important reaction, more like, the approach we took to get there.
And I like your approach also because it implies that you have to participate to make science. You send 1,000 requests, you got back only a few hundreds. And those people, which were not ranked, but only those people that they decide to participate, they were invited to a further discussion. This is something that I would like to highlight because science is also participating, right?
Science is very much about participating, and there's a request of feedback that come out all the time. And, request of feedback on the next white paper, on the next roadmap about your field. There's a request of feedback, and they come all the time. It's only difficult sometimes to find the time to give feedback to the community of this kind of initiative, but I think participation in this kind of thing is very, very important, and can also, at the end, help you and your career and your visibility. So it's both a service for the community and a service for yourself.
Donato, we are in a conversation with Donato Giovannelli, professor at the University in Naples in Italy. What is the direction of your future? Where are you going now?
I've been thinking a lot about feedback between the evolution of metalloprotein, oxidoreductases, and the availability of trace elements on our planet. And I'm very, very excited about that, because at the fundamental level, the majority of the biogeochemical reactions that happen on our planet, they happen by being of metal or protein oxidoreductases, redox chemistry carried out by biology. And I think that's an area that is really getting me excited in the last couple of years, and where I'm concentrating a lot of my work. And I think that the time is right to collect, to find out how much interaction between metals and biology really has happened through time.
Will you remain in Italy, living and working in Italy?
I've been outside Italy for almost 10 years, and I've been back since 1 year, so I'm pretty sure for a while I'll be in Italy. What I like of my job right now is the combination between my time at the university and field work. And if the one thing I really want to keep is fieldwork activities, and I hope I'm never going to stop to do them. So I'm pretty happy to stay in Italy if I can spend 2 or 3 months a year on the field.
Good for Italy. Donato, we have 3 more minutes, and I would like to give you the mic, and so that you can express yourself, say those things that you couldn't say, give your shout-outs, talk with your students, your colleagues, and the radio waves are yours.
Thank you, Daniel. Big opportunity here. I think when I want to loop back to the start, when we spoke about excitement, about exploration, and excitement about knowledge, about unknowns. I think sometimes we don't give enough credit about the emotional side of science. Science is a big emotional ride for scientists. We invest a lot of time and emotion and hopes on what we do. Sometimes we even get too emotionally attached to our own theories. But at the end of the day, that's what keeps us going. That's what makes our heart pump for science. And I think the way scientists have been portrayed in the media and outside has been dehumanized a bit, how scientists are. And I really would like to see a TV series about science that we can call the raw science, a TV series that shows the human side of scientists, not the fake drama. I really want to get the people excited about the everyday work we do, get the people excited about discovery in ways that I don't think has been done so far. And when I talk to my students, I always start about this. I always start to talk with them about how exciting it is to get something new done or discover something new. And I really hope we can do a better job with the next generation of getting them excited about knowledge for the sake of it, not just for application or for some other type of secondary use.
Donato, I really agree with you, and you make me think that I would like to collaborate with you. And yeah, this is so exciting to have you here talking with our audience and linking our beloved studies of geoscience to society at large, to talk with the students, with our parents, preparing the next generation of citizens, and obviously, as you said, advancing the human knowledge. This was another program of the Mini Geology radio show at KPFT, HD2 channel in Houston, Texas. This is Daniel Minizini, your inquisitive geologist. You can reach me at minigeology@gmail.com. You can listen to Donato Giovannelli, professor from University of Napoli, in the YouTube channel Mini Geology. And please send feedback to let me know what you would like to listen, what you would like to discuss. Propose yourself to come and be a guest. You can come and knock at the door, our 419 Lovett Boulevard in the heart of Montrose, here in Houston, Texas. And you will find a lot of fun and passion in here. Thank you very much, Donato, once again.
Grazie Daniele, un abbraccio.
Un abbraccio.
How I love you, darling, how I love you, baby, how I love you, little girl. Baby, since I've been loving you, yeah, I'm about to lose my worried mind. Ah, yeah. Everybody trying to tell me that you didn't leave me no good. Try